This screencast video attempts to show you how you can use a Google search engine as a calculator to do financial formula-based problems like the practice problems that are in front of you here that I just showed you how to use the handheld TI-84 graphing calculator. You can also do it in the Google search engine. So these are the same four problems we're about to do in Google. Notice that if I open up Google and in the search engine, I can start typing numbers and it will calculate just like a calculator. So the first problem was investing $12,500 in a one-time lump sum deposit of 5.375% APR compounded daily for 7 years. So you have to put the asterisk for multiplication and multiply the 12,500 times the base of 1 plus the decimal form of 5.375% is 0.05375. Remember, this was compounded daily, so the end value of 365 is to be used. And that needs to be raised to a power. So we'll use the caret key and put the ny value of 365 times 7 in the parentheses. You notice as soon as you push that, the calculator pops up, and to the closest penny after that, 6 after that 3 would make that 3 round up to 4 would be $18,209.64. So that 3 right there would be a 4 after the 6 rounded it up. So the second problem was investing $375 every month for 28 years when earning 6.19% APR compounded monthly. I'm just going to clear all that out and start over and start with the $375 per month. Again, we need to use an asterisk for multiplication. I'm opening a parenthesis for the entire numerator, which is the bigger of the two items in the fraction, and we are going to get a big amount when making this commitment to 28 years of monthly payments at 375. So the numerator has two open parentheses, one for the entire numerator and one for the base of 1 plus the decimal form of 6.19% is 0.0619. It's compounded monthly, so the end value of 12 is to be used. You can take that base and close the parenthesis, and then raise that to the power of 12 times 28. But once you do that 12 times 28 in parentheses, close the parenthesis, and you have to subtract 1. That's part of the formula. Now that I close the parenthesis, that's the entire numerator. I'm going to divide that by the entire denominator of 0.0619 divided by 12 to round out the formula. When I push enter, you will see that that account grew to $336,851.53. Again, the 7 would round that to up to a 3. So this is also an answer where the answer would be rounded up. Question number 3 asks, what monthly payments must be made in order to build a college account, presumably up to $160,000 when earning 4.75% APR compounded monthly for 16 years. So we start off with the $160,000 that we want this account to be worth after 16 years of regular monthly payments. And we're trying to find what those monthly payments have to be. This is the problem that has the smaller thing in the numerator because the monthly payments are quite a bit smaller than the amount that will be in there at the end. So this just requires the APR of 4.75% in decimal form over 12 because it is compounded monthly. So I added the division bar for 12 there. And now I'm going to put the fraction bar, the division bar for the entire fraction. And now all of the denominator will be written. So I'm going to put an open parenthesis for the entire denominator, another open parenthesis for the base, which is 1 plus the decimal form of 4.75%. Oops, forgot my 0. There's got to be a 0.0475. Divide that by 12 for compounded monthly, and you're going to raise that to the power of 12 times 16. Because this person presumably started when their kid was 2 years old, so that when they're 18, they'll have this $160,000 ready for this kid's college education. So after all of that, you have to subtract 1. Again, that's part of the formula. And we push enter. We see that means that after rounding, the 8 would round the 6 and the hundreds place up to 7. So it'd be $557.97 after being rounded up. All three of our answers have matched what we did on the graphing calculator. So let's round it out with our fourth problem, which was what must be What will be the monthly payments if I borrow $28,000 to buy presumably a car with a 5-year loan with 3.99% APR compounded monthly? So we start off with the amount that we borrowed, which is referred to as a principal. And with Google, you do have to use the asterisk in front of parentheses to tell it needs to be multiplied. Again, the monthly payment is a small amount. So the smaller part of the fraction is in the numerator, and it's just the APR over n. So the decimal form, 3.99% is 0.0399. We are dividing that by 12 because, again, the payments are done monthly. That means the compounding will be done monthly. This division bar is for the fraction bar, and everything in the denominator is now going to be enclosed in parentheses. Different formula. It starts off with 1 minus the base. I have to open a parenthesis for, which is 1 plus, again, the APR of 0.0399 for 3.99%, divided by 12 for compounded monthly. And the difference with this formula is you're raising it to the negative ny power. So I'll use the caret for the exponent, open a parenthesis, and negative 12. Be careful. Yeah, I think you can use the minus button actually in Google, or the dash button for minus on your keyboard, because Google will read it as a negative, especially when you put the asterisk after that negative 12 and put the appropriate 5 because this is a 5-year loan. So when we push enter, you'll see that the answer is a fourth answer in a row that was rounded up. The 6 here after that 3 rounds that 3 up to a 4. So you'll make monthly payments of $515.54 for 5 years when you borrow $28,000 at 3.99 APR compounded monthly. All 4 of our answers match what we did on the graphing. Thanks for your perseverance to watch the whole complete video.